So the next is the quantile plot. Earlier we have discussed about the histogram and recognition of the distributional shape in the previous video, various types of the distribution. They are a necessary ingredient for selecting a family of distribution to represent a sample data. However, a histogram is not as useful for evaluating the fit of the chosen distribution when there is a small number of data points, say 30 or few. A histogram can be rather ragged. Further, our perception of the fit depends on the width of the histogram interval. But even if the intervals are chosen well, grouping data into cells makes it difficult to compare a histogram to a continuous probability density function or PDF. Okay, a quantile for that purpose, wherever a histogram doesn't suits well, that is wherever the samples are few or fewer number of samples we have, in such cases we can go with quantile plot or QQ plot. Very simple to understand. Wherever histogram doesn't suit, or wherever histogram you feel it is the number of collected samples are insufficient for representing in terms of histogram, in that case we can go with the QQ plot, that is quantile plot. It is one of the useful tool for representation of the sample data. Okay, let us see what exactly it is then. If x is a random, hope it is visible now. Yeah, if x is a random variable with the CDF f, capital F, when then the quantile of x or QQ of x is the value of gamma such that f of gamma, as per this is what the thesis. So f of gamma, which is equal to P of, where P is the probability, okay, P of x, which is less than gamma, or you just mark it as Q or quantile. This is the definition. Okay, for the range of Q, then what is the range of Q then? Range of Q again very simple to remember, it lies between 0 and 1. When f has an inverse, we write for the inverse functions, how to represent the inverse function? Write gamma now. Okay, f of gamma we are not considering, we are just considering gamma now, which is equal to gamma, which is equal to f inverse of Q. That's it, f inverse of Q, inverse function of that quantile. That's it. Now let the value of xi be whatever value of I ranges from 1 to n number of samples that represents, be a sample of the data from x, the CDF. Okay, order the observation from the smallest to the largest. This is required. Earlier also we have done it. Ordering of the data, arranging the data in ascending order, smallest to largest, and denote this as, after ordering, mark it as yj. Earlier we marked it as xi now. So now after rearranging them, use the different notation, say yj, which is equal to, where j equal to 1, 2, 3, 4 and so on up to n, where y1 is less than or equal to y2. This is what reordering of the sample data. Okay, y1 is less than or equal to y2 and so on up to yn. This is one of the easiest step and very simple to remember. Okay, let j denote the ranking or order number. That's it. J is 1 for smallest number, j is n, which represents the largest among them. The QQ plot or quantile plot is based on the fact that yj is an estimate of the what? J minus half divided by n quantile of x. That is what, that is they are saying as per the thesis, they are saying yj is approximately, what is, how to compute yj then? Yj, which is approximately equal to f inverse of j minus half divided by n, j minus half divided by n. Okay, now suppose that we have chosen a distribution with the CDF f as a possible representation of the distribution of x. If f is a member of an appropriate family of distribution, then a plot yj yj plot versus this one f inverse of j minus half by n is it will be approximately a straight line. Okay, straight line, that is nothing but after plotting the points we'll be getting a straight line. If f is from an appropriate family of distribution and also has appropriate parameter values, then the line will have a slope 1, then the line will have a, it will pass through, so it will have a slope 1 in the sense it will pass through origin a straight line for almost 45 degree it will pass through. On other hand, if the assumed distribution is inappropriate, the points will deviate from the straight line, usually in a systematic manner. Okay, the decision about whether to reject some hypothesized model is subjective. So it all depends on the representation of or plotting of the point. It all depends on how we choose the distribution function. Okay, it can be a straight line, it can be a straight line of slope equal to 1, or the point may deviate, as that is what they are trying to explain you. Let us better discuss with an example. I will be considering the example in my next video. Please note down all these things. So theory part, these things easily you can study, things you should remember. Okay.